Parametric design. Parametric design allows us to easily modify the object through geometry constraints or dimension constraints. It helps to save time, improve production efficiency, since it avoids manually editing every parameters of the object whenever we want to make a change. And meanwhile, the parametric design function can be a really good assistant to make the user more professional. For example, open the file. We will only change the degrees with all the other parameters stay the same. Left-click on angular dimension first, and then left-click on the blue node on the edge of the object and drag it to change. Or set the value directly with an accurate degree in the Design Central. We can also only change the radius. Same as just now, left-click on the radial dimension first, and then find the blue node on the edge of the arc. Drag it to change. Or set the value directly with an accurate length in the Design Central. That is a simple demonstration of how the parametric design works. And next, we will have a detailed introduction of each function under the geometry constraints and dimension constraints. Draw a rectangle. Go to Parametric and choose Geometry Constraint. In the Design Central, we see that the geometry constraints include horizontal, vertical, parallel, perpendicular, tangent, concentric, coincident, equal, point on curve, collinear, symmetric, fixed, and same constraints. First, take a look at the horizontal constraint. Before we apply the horizontal constraint to this rectangle, when we drag any of the nodes, the shape can be changed freely. But by horizontal constraint, go to Parametric, choose Geometry Constraint, and select Horizontal. Left-click on the edge of the object to set horizontal constraint for that certain edge. Now, with the horizontal constraint, no matter how we move the node, this edge will always stay horizontal straight. Parallel constraint. For these two edges, without parallel constraint, either of the two can be changed. Set the parallel constraint. Select the first line and select the second line. And we see they are parallel to each other. Drag either of the two, they will stay parallel. We can also realize dimension constraint while keeping the geometry constraint valid. Go to Parametric and choose dimension constraint. In the design central, we see that dimension constraint includes linear dimension, radial or diameter dimension, angular dimension. For example, we try linear first. Choose the linear dimension and left-click the mouse to select the edge. The style of the dimension can be changed. Go to Parametric and choose Dimension Style. Change the font, size, character space, and size of the arrow, and etc. And click Select All Dimensions and update selected dimensions. Through dragging the node of the edge, you can change the length. And please notice that the geometry constraints we have already set are still valid. They are parallel to each other, and this one is horizontal constraint. Now take a look at the tangent constraint. Open the file. This arc is tangent to these two edges. If we randomly move the node, they won't be tangent anymore. But with tangent constraint, go to Parametric and choose Geometry Constraint and select Tangent Constraint. Select the first curve and the second curve, and do it again. Select the first curve and then the second curve. Now we see that when we move the arc, it still keeps tangent to the two edges. For a concentric constraint, it means circles or arcs share the same center. With no concentric constraint, this circle or this arc can be changed separately. Now we add concentric constraint between the two. Select the first circle or arc, and then select the second circle or arc. And now this circle and this arc are related by the same center. And we see that when we move the arc, the circle also moves together. Next one, equal constraint. The equal means the radii of the circles or arcs or the length of the lines are the same. Here we set equal constraint to these two circles. Select the first curve and then select the second curve. Then we add radial dimension for this circle. Go to Parametric and choose Dimension Constraint and select Radial Dimension. When we change this circle, we see that the other one is changing equally. Besides, not only these two circles, we can also choose several circles and change them all together. And now we will use another example to explain the rest of the constraints. Draw a triangle. And draw a circle. Hold down Shift to make two copies of it. Go to Parametric and choose Geometry Constraint. And select the coincident constraint. Coincident constraint means that the two selected points will coincide with each other. Select the first point and select the second point. First and second, first and second. Now we see that the circle and the triangle are coincide with each other. Now move the coincided point, then the two graphs move together. Next one, point on curve. Draw a straight line and go to Parametric, Geometry Constraint, Point on Curve. First select the point and then select the curve. Then this point is constrained to move only along the line, but the position of the line will be changed when we move the point. However, we can set the fixed constraint to make the line stationary. Go to Parametric and choose Geometry Constraint and select Fixed Constraint. Select the point and select another point. Now we try again. And now we move the point on the curve and we see the line stays the same while the point can be moved along the line. Angular dimension. Go to Parametric and choose Dimension Constraint and select Angular Dimension. Select the two edges of the angle and then left-click the mouse to set. Edit the angular dimension to change the angle. Next one, same constraint. Same constraint will make the transforming object change in the same way as the reference object. For example, open a file. Go to Parametric and choose Geometry Constraint and select Same Constraint. First, select the object to transform and then select the reference object. When changing the reference object, we see that the transforming object are changing according to the bounding box of the reference object. Except the geometry and dimension constraints, there's also an auto constraint. And auto constraint will automatically realize all the geometry constraints of the object. Here we set auto constraint to the reference object. These little green marks show us that the constraints are added to the object. And now, when we move the reference object, we see that the same change is achieved between the transforming object and the reference object. Last one of the geometry constraint, symmetric constraint. This is a symmetric rectangle. Draw the midline. And this is the symmetric line. Without symmetric constraint, when we drag the object, we see that it may be not symmetric anymore. Apply symmetric constraint to this object. Select the first point and the second point, and select the symmetric axis line. And now we see that the object changes symmetrically. At last, we will see how to delete the constraints we have already set. There are two ways. Select the part of the object that we want to delete the constraints, and right-click the mouse on the green constraint mark, and then click Delete. Or we can go to Parametric and choose Delete Constraints, and then right-click to select the curve. This action will delete all the constraints we set on the curve. And that's the end of the parametric design tutorial. Thank you.